there is a planet. It orbits a star. It sits in what scientists call the habitable zone, the narrow band of distance where liquid water can exist on a surface, where life, as we understand it, might be possible. It is roughly the same size as Earth. It is rocky. It has been in that zone, undisturbed, for longer than our entire solar system has been alive. And it is the closest ProximaB, closest exoplanet, habitable zone world we have ever found. 4.2 light-years away. That's the distance. 4.2 light-years. If you stood outside tonight and looked toward the southern sky, the star it orbits, Proxima Centauri, would be invisible to the naked eye. Too faint, too red, too small. But it is there, and so is the planet. ProximaB. ProximaCentauriB, the nearest world that science says could, under the right conditions, support life. And here is the thing that should stop you cold. We will never reach it. Not with anything we have built, not with anything we are building, not in your lifetime, not in your grandchildren's lifetime, not in any lifetime connected by memory or story to the one you are living now. We found it. We named it. We have studied it from across the galaxy, and it is impossible to reach. So the question is, why are we so obsessed with a world we will never touch? In August of 2016, a team of astronomers based at the European Southern Observatory in Chile made an announcement that quietly rewrote our understanding of our cosmic neighborhood. They had spent months watching Proxima Centauri, the single closest star to our sun, wobble, just slightly, just enough, a tiny gravitational tug pulling the star toward them and then away, over and over, on a cycle of 11.2 Earth days. Something was orbiting it. And when they ran the numbers, what they found was a planet, a rocky planet, with a minimum mass just slightly larger than Earth's, sitting at a distance of 0.05 astronomical units from its star, closer than Mercury is to our sun. But because Proxima Centauri burns so much cooler and dimmer than our sun, that distance placed it squarely inside the habitable zone. They called it ProximaCentauriB, and the scientific world held its breath. Here is what makes this discovery so staggering. The search for an Earth-like world in a habitable zone has consumed decades of observation, billions of dollars in telescope infrastructure, and the careers of some of the greatest minds in modern astronomy. And the first serious candidate turns out to be right next door, 4.2 light-years away, the nearest possible neighbor we could have. It is like spending years searching the globe for a kindred spirit, only to look up and find them standing at the end of your street, except you have no way to walk down that street. To understand why, you first need to understand what 4.2 light-years actually means. Not as a number, as a distance you can feel. Light travels at roughly 300,000 kilometers per second. In 1 second, it crosses the distance from here to the moon 7 times over. In 8 minutes, it crosses the entire distance from Earth to the sun. In 4.2 years, 4 years, 2 months, and a handful of days, it crosses the distance to Proxima Centauri. That is the speed of the fastest thing in the universe. And it still takes 4 years. The fastest spacecraft humanity has ever launched is the New Horizons probe. We sent it to Pluto, and it arrived after 9.5 years of travel, covering about 3 billion miles. At that same speed, pointed directly at Proxima Centauri B, it would take New Horizons approximately 80,000 years to arrive. 80,000 years ago, Homo sapiens had not yet painted the first cave walls at Lascaux. We had not invented agriculture. The entire span of recorded human history is a tiny fraction of that travel time. That is the gap between us and the closest possibly habitable world in the known universe. And that should have been the end of the story. a distant world, interesting, unreachable. But Proxima B keeps pulling astronomers back, not because it is the most Earth-like planet we've found. It isn't. Not because it is the most promising candidate for life. We don't know that either. The reason is much simpler. We don't have a better option. Among the thousands of exoplanets discovered so far, this remains the closest potentially habitable world we know of. 4.2 light-years, the nearest place beyond our solar system where life might exist. A planet orbiting a violent red dwarf. A planet we may never reach. A planet that might be completely dead. And yet, compared to everything else we have found, it is still our nearest chance to answer the oldest question humanity has ever asked. Are we alone? But there is another problem. Distance is not the only reason Proxima B fascinates scientists. The deeper mystery is that, by many measures, this planet should not be habitable at all. In fact, if you look at the system it lives in, the surprising thing is not that we haven't found life there. The surprising thing is that anyone still thinks life might be possible. Because almost every major feature of Proxima B seems designed to make life difficult, which raises a question. If this world really has any chance of supporting life, what are we missing? ProximaCentauriB is almost certainly tidally locked to its star. Tidally locked. It means the same side of the planet always faces the star. One hemisphere in permanent, endless daylight, the other in permanent, endless night. The planet does not rotate the way Earth does, cycling through mornings and evenings and seasons. One face bakes, one face freezes, forever. We know this because of how close the planet orbits. At 0.05 astronomical units, the gravitational pull of Proxima Centauri is so overwhelming that over vast stretches of time, it would have slowed and stopped the planet's rotation entirely, locking it in place, the way Earth's gravity has locked the moon so that we only ever see one face. What that means for the surface is hard to picture and harder to survive. The day side could be scoured by heat and radiation. The night side could be cold enough to freeze any atmosphere solid. And in between, at the terminator line, the narrow ring where day meets night, there might be a zone of perpetual twilight, where temperatures could theoretically stabilize, where liquid water might pool, where something might live. But there is a bigger problem than the tidal lock. The star, Proxima Centauri, is what astronomers call an M-dwarf, a red dwarf, small, cool, dim, emitting only a fraction of the visible light our sun produces, but it compensates for its dimness with violence. Red dwarfs are flare stars. They erupt regularly, savagely. Proxima Centauri has been observed releasing superflares, bursts of ultraviolet and X-ray radiation so intense that, on Earth, the equivalent event would strip away the ozone layer, expose the surface to lethal radiation, and potentially sterilize everything that breathed open air. Proxima B receives 30 times more extreme ultraviolet radiation than Earth does from the Sun, 250 times more X-ray radiation. During a superflare, the radiation dose hitting the surface, without protective atmosphere, would be 65 times the level needed to kill 90% of the most UV-resistant organisms we know of on Earth. And Proxima Centauri does this routinely. Now add to that the question of atmosphere. Does Proxima B even have one? We don't know. We cannot directly observe it. But what we do know is that the same radiation and stellar winds that make the surface so hostile have been hammering this planet for billions of years. Computer models suggest that an Earth-like atmosphere on Proxima B could be entirely stripped away within 100 million years, a fraction of the planet's total age. Without atmosphere, there is no pressure to keep liquid water on the surface. Without pressure, Water either boils or sublimates in a vacuum. Without water, there is no known pathway to life. This is the reversal. This is the thing the discovery doesn't tell you when you first hear it. We found the closest possibly habitable world, and it might be a radiation-blasted, atmosphere-stripped, tidally frozen shell of rock where nothing as we understand life, could survive. And yet, science is not finished with ProximaB, not even close, because every catastrophic fact about this planet has a counter-argument. Every reason it should be dead has an answer, and those answers are just plausible enough to keep the question open, suspended, unresolved, electric with possibility. Consider the tidal lock. Yes, one side bakes and one side freezes, but the models have been refined. If ProximaB has a sufficiently dense atmosphere, say an atmosphere thicker than Earth's, loaded with carbon dioxide or other greenhouse gases, that atmosphere could circulate heat from the day side to the night side continuously, moderating the extreme temperatures on both faces. The terminator line would widen, the habitable region would grow. A planet that looks like a death trap from a distance might, under the right atmospheric conditions, sustain temperatures suitable for liquid water across a significant portion of its surface. Consider the radiation. Life on Earth evolved in an ultraviolet environment. Our earliest organisms didn't have an ozone layer protecting them. They developed in the oceans, shielded by water, which absorbs UV radiation efficiently. Life on ProximaB, if it exists, might have evolved the same way, underwater, sheltered, thriving in the radiation shadow of an ocean floor, while the surface above it was periodically sterilized by stellar flares. Life that never needs to see its own sky. We genuinely do not know, and that not knowing is one of the most profound things in science right now, because the answer, whatever it is, changes everything. If ProximaB is dead, it tells us something important, that the universe produces habitable zones easily, but that the stars surrounding them can be so hostile that life never gets purchase, that the cosmic neighborhood may be full of near misses, zones that look warm and promising from the outside, but are silently lethal. If ProximaB has life, even microbial life, then we are not alone. And not alone in a theoretical, philosophical sense. Not alone in the way you are not alone knowing that there are people in cities you have never visited. Not alone right next door, 4 light years, the nearest neighbor, a kindred chemistry in the closest place it could possibly be. Both answers shake the foundations of how we think about our place in the universe, and right now, we cannot tell you which one is true. So why does this planet haunt us? It is not just the science, it is something older than the science. Something that was running in us long before we had telescopes or data or the mathematics to detect a wobble in a distant star. It is the same impulse that made early humans climb hills to look at the horizon, that made Polynesian navigators cross open ocean by starlight alone, that made every civilization that ever looked up at the night sky ask, "What is over there?" ProximaB is the answer to that question made concrete, made measurable, made real. For all of human history, other worlds were mythology. They were gods, they were stories. Even after Copernicus, even after Galileo, even after we understood that the stars were distant suns, the idea of another Earth was still a thought experiment, a philosophical position, something to argue about, not something to point at. And then we pointed at it. In 2016, we pointed at a specific dot of light in the southern sky and said, "There is a planet there. It is rocky. It is in the habitable zone. It might be like Earth, and it is the closest one we know of." That changed something, not in policy, not in funding necessarily, but in the imagination, in the deep, quiet, animal part of the human mind that processes proximity and possibility simultaneously. But impossible and unreachable are not the same thing. There are serious proposals on the table right now. Real proposals, funded proposals, to send robotic probes to Proxima Centauri within this century. The Breakthrough Starshot initiative, backed by some of the biggest names in science and technology, has proposed a swarm of gram-scale spacecraft no larger than a postage stamp, propelled by a high-powered ground-based laser to 20% the speed of light. At that velocity, the journey would take just over 20 years, not 80,000 years, 20 years in a human lifetime. With technology that does not yet exist, but does not violate any known law of physics, these probes would not carry humans. They would carry sensors, cameras, and when they arrived, when they swept through the Proxima system at a fifth the speed of light, they would have only minutes to observe the planet before passing beyond reach. Minutes to send back the first close-range data we have ever received from another star system. The first image, the first atmospheric reading, the first real answer. We might, in our lifetimes, see a photograph of ProximaB, not boots on the ground, not a colony, not a second Earth, just a photograph, just light reflected from a world 4.2 light-years away, captured by a sensor the size of a stamp and beamed back across the void. But what a photograph it would be! Here is what makes ProximaB different from every world humanity imagined before it. For most of history, other worlds belonged to mythology, then to philosophy, then to science fiction. ProximaB belongs to none of those things. It is real. Right now, as you watch this, a rocky planet is circling the nearest star beyond our sun, and somewhere around it, the answer already exists. Dead or alive, foothold or void. We are simply the only ones who don't know yet. For the first time in human history, are we alone isn't a question aimed at the universe in general. It has a coordinate, a name, 4.2 light years. Somewhere out there, right now, the answer is waiting. We just have to go get it.